Hi everyone, welcome to this coding series. So in this series we will go through each questions which were asked in Google interview. So yeah, let's start from the first question. So the question is subarray with the given sum. So, given an unsorted array of size n that contains only non-negative integers, find a continuous subarray which adds to a given number s. In case of multiple subarrays, return the subarray which comes first on the moving from left to right. So, yeah, let's first understood the question. So, yeah, the question says like we have given this array 1, 2, 3, 4, 5, and let's say s is given to 9. So, we have to find a sub array whose sum is equal to this s. So yeah, as we can easily see, 2 plus 3 plus 4 is equal to 9, and there can be another subarray 4 plus 5 equal to 9. But the question says we have to return the leftmost subarray, like the subarray which comes first from the left to right side. Yeah, so the answer would be from the subarray from 2 to 4. So 2 comma 4, the left index is 2 and the right index is 4. So yeah, that's we have to find. So this question be easily solved by naive approach. What we can do is we can simply use two for loop. The outer loop will point to the first element, and then the inner loop move move to the all the next element and calculate the sum, and so on. And whenever we reaches the condition thus where our current sum is equal to this s, so just return those indexes I and j. But the interviewer won't be satisfied with the naive approach. They'll ask to optimize it. So what we can do is we can take two pointer. One is left and another one is right pointer. So the left pointer will point to the first very first element, and the right pointer would be at the next element. And we will use the sliding window approach. So we will keep on adding this, right? Like 1 plus 2 3, and then we'll increase our right pointer, then 3 plus 3 6, and then we'll increase keep on increasing the right pointer until we exceed the sum s. And let's say here we reaches here, so here our sum become 10, which is greater than s. So now we will decrease our left point, so now we'll increase our left pointer and subtract the leftmost element from our current sum. So now the 10 minus 1 would be 9, and our L would be here. And if so here the condition matches, right? Our sum is equal to this s, so we can return this. So yeah, let me walk you through by an example, and then we'll code the solution. So initially our sum would be, we can divide sum equal to array of 0. So 0 array of 0 is equal to 1, right? So initially our sum is this, sum is equal to 1. So now what we can do is we will keep on increasing our right pointer until our sum is less than n, right? So now if sum plus 1 plus array of r is less than s, right? Let me write this. So if sum plus array of r is less than s, then what we need to do, we have to increase our sum by array of r and just r equal to r plus 1, right? So now initially what our sum is 1, sum plus array of r. So 1 plus array of r is pointing to this 2. So 1 plus 2, 3, and 3 is less than 9. So our sum would be sum plus array of r. Sum will become 3, and r equal to r plus 1. R will be 2, right? And now again our sum is less than, and so less than s. So sum plus array of r is sum plus array of r. R is pointing to, now pointing to 3. So 3 plus 3, 6 is still less than s. So our sum will become 6, right? And r will be 3. Now the next condition. So now 6 plus 4, 6 plus 4 is 10, which is greater than s. So we need to write that another condition, right? Else if sum plus r exceed our given s given sum. So what we have to do, we have to subtract the leftmost element. So sum minus array of l and increase l by 1, l equal to l plus 1. So what it will become here. So now we will go into the else condition. So sum would be sum minus array of l. So 6 minus 1, it will become 5, and l equal to l plus 1. So l would be at 1. Now 5, now again sum plus array of r. 5 plus r is still pointing to 4, so 5 plus 4 is 9, which isn't less than s, because it is equal to 5 plus 4, 9, 9 equal to 9. So now the condition came, s equal to our current sum is equal to this, right, equal to s. So we can write here is l if sum plus array of r equal to s, then just simply return l comma r. Or we can return l plus 1 comma r plus 1, because the counting start from they are treating it as instead of zeroth index, they are starting from the first, they want output from the first one, right? So now let's go to the solution what we have discussed in our algorithm, right? So what we'll do, we'll initialize the two pointer left and right, whose initial value would be 0 and 1, and our current sum, initial sum would be equal to array of 0, and we can check here if our s equal to sum. So like s is given to the very first element, like if s is given to us 1, if s is 1 instead of 12, then what would be the answer? It would be 1 comma 1, because the very first element is 1, right? So we can check that condition. If s equal to sum, then just simply return 1 comma 1, right? And now let's go to the actual solution what we have discussed. So while our right is less than n, what we have to do, we have three conditions, right? The first one is if current sum plus array of right is less than s, then just sum equal to sum plus array of right, and right equal to right plus 1. Just keep on increasing the right. So now like if sum is less than s, then we are keep increasing our right pointer, right? And l if sum plus array of right equal to s, right? This satisfies the condition. So here what we'll do, we'll return this sub array index, right? Left plus 1 comma right plus 1, and else what we'll do, we will subtract the leftmost element sum minus array of left, and increase the left pointer, left equal to left plus 1. So yeah, like that is the algorithm. And if none of these conditions satisfy, like there is no solution, so what we can do, we can simply return minus 1, right? Yeah, but there is one more edge case, right? So what we can do is if s equal to 0, just simply return minus 1. And yeah, now let's compile our code and see and check our solution. So yeah, this test case passed, so let's submit the solution, and it's evaluating. Yeah, we have solved the problem, right? So you can also try it out by yourself, just simply going through the algorithm and try to code it yourself in in the whatever programming language you like. So yeah, have fun and keep enjoy coding. Thanks.